Hey guys, how you doing? This is Coach Hutchison again. This is the video for your test review. This is a study guide to kind of go through. We're going to go through this together. And I would suggest, of course, watching this. And if you're watching it now, I would suggest to continue watching it so that you know that you'll be ready for your test tomorrow. Okay, so really quick, if you look at these parts of the atom, this was something we did a while back. We need to make sure that we know that this is the nucleus. This right here is pointing to a positive particle inside the nucleus, so that would mean that is a proton. This is pointing to a non-charged particle in the nucleus, so that would mean this is a neutron. This electron right here, these are both electrons, all three of these orange dots, okay? And then specifically though, this one right here, because it's in the outer level, that one specifically is a valence electron. Remember, valence electrons are those electrons in the outer shell. And then this bracket here is talking about this entire area where all the electrons exist, and that is going to be the electron cloud. Okay? All right. So first question, name the subatomic particles. We should be able to name these three things that are located inside of the atom. We just identified them in the diagram below. Those are protons, neutrons, and electrons. What two subatomic particles belong in the nucleus? So think about it for a second before I reveal the answer. The two particles inside the nucleus, remember, are the protons, positive, and the neutrons, which are neutral or no charge. Which subatomic particle has a positive charge? The proton. Which subatomic particle has a negative charge? A lot of students get confused because they say P, proton, P, positive, and then they say negative, and they automatically say that it's a neutron. But remember, it is the electron that is negative. The subatomic particle that has a neutral or no charge is located in the nucleus alongside the protons. When we add the protons and this particle together, we get the atomic mass of an atom. So the particle is a neutron. Subatomic particle charges. Okay, remember that protons are positive, neutrons are neutral or no charge, and electrons are negative. Where are the electrons located? These are located outside of the nucleus, and that part of the atom that's outside of the nucleus is called the electron cloud. Now, inside the electron cloud are the energy levels, and remember, the energy levels have different numbers of electrons that they can hold, different numbers of maximum number of electrons that they can hold. So what is the atomic number? Okay. The atomic number, remember, tells us it's located right here, A. Okay. So if they give you a question that tells you how many protons there are, P, then that also tells you the atomic number. If they tell you how many electrons there are, that also gives you the atomic number. Okay. So remember, the atomic number is the number of protons in the nucleus. Remember, protons are the identity particle, and so it is the proton that is the most important particle. The atomic mass, remember the atomic mass right here, M in ape man, mass minus atomic number gives us neutrons. So if we take the atomic number, or protons, which are the same, right? Protons plus neutrons will give us the mass. Okay, so the number of protons and neutrons in the nucleus. Protons have an atomic mass of 1. Neutrons have an atomic mass of 1. And so when we add the protons plus the neutrons together, we get the atomic mass of the atom. Electrons do not factor into the mass. So how do we calculate the number of neutrons in an atom? Again, remember the ape-man rule, M minus A equals N. So we subtract the number of protons from the atomic mass, and that will give us the number of neutrons. So protons plus neutrons equals mass, or mass minus protons gives us neutrons. How many electrons can go in the first energy level in the electron cloud? It's right there highlighted in yellow. The first energy level can hold a maximum of 2 electrons. In the second energy level, the max number of electrons that it can hold is 8. It can hold less, but it cannot hold more. How many electrons can go in the third energy level in the electron cloud? Again, here it is right there. Again, it can hold less than 8, but it can only hold a maximum of 8. So groups in the periodic table. Remember, the groups are the vertical columns up and down. Okay, they go through 1 through 18, left to right on the periodic table if we look at the top of the periodic table. And the group number tells us the number of valence electrons inside all the atoms that are in that group. So group 1 elements all have 1 valence electron. Group 2 elements all have 2 valence electrons. Group 13 elements all have 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and group 18 has full outer shells. Remember that a valence electron, so there are a total number of electrons that an atom has. Remember, that's equal to their protons. But there are some special electrons, and there's not really special about them individually. What's special about them is where they are located. Remember that valence electrons are located on the outermost energy level in the atom, or what we call the valence shell. So in this drawing here, there are 1, 2, 3, 4, 5, 6, 7 total electrons. Okay, so that would tell us if there are 7 electrons total, there would be 7 protons in there. And of these 7 electrons, only 1, 2, 3, 4, and 5 are valence electrons. So this neutral atom should have 7 protons. So if there are 7 protons in this atom, the atomic number of the atom is 7. And if we look on the periodic table, we will find that the element that has an atomic number of 7 is nitrogen. How many neutrons does this atom have? Okay, so we know that there are 4 protons in the nucleus. Okay, so if we wanted to determine how many neutrons were in this atom, we would have to find the mass of the atom. Okay, and so number 4 tells us that this is the atomic number 4, which is beryllium. Okay, and if we go to the periodic table, beryllium is number 4. It has a mass of 9.0. Okay, so the mass of 9.0 minus 4 would give us the answer of 5 neutrons. Let me get back to where I was. Apologize for that. Okay, so the periods. So we talked about how the groups tell us the number of valence electrons. The periods tell us the number of energy levels that are inside the atom. Okay, so period number 1, all the elements in period number 1 have 1 energy level. All the elements in period number 2 have 2 energy levels. And the periods in period number 3 have 3 energy levels. So we can tell what period this element belongs in simply by counting the number of energy levels it has. So it has 1, 2, 3 energy levels. That would put it in period number 3. This element is aluminum, atomic number 13. So how many protons would this neutral atom have? All right, so remember, A equals P equals E. So if they don't give you protons, if you count the number of electrons, it will tell you how many protons there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 electrons. That means there are 9 protons. And if there are 9 protons, that means this atom is atomic number 9 on the periodic table, which is fluorine. What period does this atom belong to? Okay, again, count the energy levels. There's only 1. Okay, so the period that this atom belongs to would be in period number 1, which means that this atom either has to be hydrogen or helium, but it would be helium because it has 2 electrons, which means it would have 2 protons, which means its atomic number would be 2, making it the element helium. Okay. How many protons should this neutral atom have? Again, going back to A equals P equals E. If there are 1, 2, 3 electrons, that means there are 3 protons. And if there are 3 protons, this is element number 3 on the periodic table. And element number 3 on the periodic table is lithium. Neutrons. All right, so again, here we are at N. Mass minus atomic number equals neutrons. They give you protons here. These two numbers have to add up to the mass. Okay, so let me say it again. These two numbers have to add up to the atomic mass. So if you go on the periodic table and find the element that has 8 protons, which is oxygen, and you look at the mass of oxygen is 15.99, which we would round to 16. And so if the total mass of the atom here is 16, then the number of neutrons has to be 8. Valence electrons does this atom have? Again, it has a total of 1, 2, 3, 4, 5, 6, 7, 8. Okay, it has 8 total electrons, but 1, 2, 3, 4, 5, 6 of them are located in the outer shell. So that means this atom only has 6 valence electrons. What group does this atom belong to? Okay, so earlier on we talked about how the group numbers tell us the number of valence electrons. So this is just reversing the process. If we count the number of valence electrons, that will tell us the group that it's in. And so there are 6 valence electrons. So that would make this an element in group number 16. Based on valence electrons, this atom belongs in. So it's looking for the group. There are 5 valence electrons, so that would put this element in group number 15. Based on the energy levels in the electron cloud, what period does this atom belong in? Okay, energy levels 1, 2, 3. So that would tell us this element is in period number 3. But on a side note, you can also determine the group 1, 2, 3, 4, 5. So this element is in period number 3 and group number 15. What element is this a neutral atom of? They don't give you the protons, but remember, A equals P equals E. 1, 2, 3, 4, 5 total electrons makes this 5 protons. And if you go to the periodic table and find element number 5, you will find that it is boron. How do you know? I just explained it. There are 5 total electrons, and electrons has to equal the number of protons, and the protons tell us the atomic number, and therefore the atomic number of this element is 5. Group, again, remember group is valence electrons. So there is only 1 valence electron in the outermost shell. So this element belongs in group number 1. All right. So here is some practice that you can use here. So you'll just be dragging. We've done a couple of activities like this already. So you can drag these over into the appropriate shells. Here we go with 8. We want the valence electrons to be in the outer shell. So 8 total electrons. So we need to have 6 more here. Okay. So we can just put 1 there, 1 here, 1 here. Try not to overlap. Try not to move that. Okay, right there. Then we can put number 6 total there, number 7 total there, and number 8 right there. And then over here we got 10. So we would put 8 total in the outer shell. We'll go ahead and just make these all red here. So a total of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then the last thing here, remember the groups right here tell us the number of valence electrons. So all of these elements in group 1 have 1 valence electron. All of these have 2 valence, 3 valence, 4 valence, 5 valence, 6 valence, 7 valence. And in the last group, the noble gases have 8 valence electrons, except for helium, which only has 2 because it only has 2 electrons. But basically all of these elements here in this group have 1, or their last level, is completely filled, and they will never bond with another element. Okay, guys, hopefully this will get you ready for your test tomorrow. Again, if you have any questions, please email me or reach out to me on Hangouts so that we are ready to go Wednesday when we give you the test. Y'all have a great day. Bye.